right. Thank you, everyone, for joining us for the Product Development Forum based out of Chattanooga, but it's virtual, so you can join from anywhere. Today, we have Rose Karr speaking for us about Agile on the Edge, and she's with Carbon 5, and she is a software engineer and recruiting manager. And with that, I will pass it off to you, Rose.
Yeah. First off, apologies if I'm a little flimmy. My allergies are crazy today, but yeah, welcome to the Chattanooga Product Development Forum. I'm Rose. As Derry said, I'm a senior software engineer at Carbon 5. I've been a developer for about 9 years, and I've been with Carbon 5 for a little over 3. In my 3 years at Carbon 5, I've gotten the chance to work with a lot of very new, you might say, cutting edge technologies. So for this talk, I wanted to share some of what I've learned about applying Agile methodologies to these sorts of projects and what's worked for me and what's worked for the teams that I've been a part of. Your mileage may vary, all the appropriate disclaimers. Sorry. Before we get into solutions, let's talk a bit about the sort of problems we face on these sort of projects. So first off, when working with cutting edge technology, sometimes we find ourselves building things that no one else has built yet, which is a lot of fun, but it also means that we're navigating unexplored territory, which can be a problem in itself. There isn't much, if any, writing for a lot of the technical problems that we face. Worse yet, sometimes we don't even know where to start on a problem. We know that we need to learn more before we can proceed, but we might not know what it is we need to learn about. It's a bit like being dropped in a library and told we need to design an interphasic coil spanner. Before you can even design one, you need to find out what an interphasic coil spanner is. And for the curious, by the way, it's just some made up Star Trek tool that happens to look suspiciously like a fork with some foam stuck on the end. Another related problem we face, since we need to do so much learning, is how to do that without getting stuck in analysis paralysis. For the unfamiliar, by the way, analysis paralysis is just the problem of being unable to move forward because we're stuck studying a problem, not being able to move from studying to solving it. And one more problem that comes with learning is adapting what we're building on the fly as we discover more about the space that we're working in. When we're working in new spaces, we're going to make mistakes. We're not going to get it right on the first try. And the key to success is coming back for a second try and a third and a fourth and so on. But unfortunately, that's multiplying all the work we have to do in the process. Another big challenge we often face on the cutting edge is making hard decisions. We can't build everything, so we have to decide what we want to build. But deciding what to build on the cutting edge often means choosing from an infinite set of options. Because there are no well-laid paths for us to follow, everything is on the table. We can go in any direction. In a business sense, we're exploring entirely new markets where it's not clear what products our customers will want, there will be demand for, or more fundamentally, what products are even possible for us to build. Which brings up another more technical challenge. How do we answer questions that no one has asked before? We can't exactly Google something or check Stack Overflow for a common solution when there's no prior work for what we're doing. If we're building something like a content website, a blog, we would know we need things like posts and tags, authors, and categories. If we were building an e-commerce site, we would know we'd need concepts like shopping carts and checkout processes. But when we're building something totally new, we don't have any prior work to model ourselves after, which means that we don't always know what the right metaphors are or what fundamental concepts we should be working toward. We can look at related problems for inspiration and study generic best practices, but ultimately for our specific use cases, we have to figure everything out on our own. Sorry, I clicked off the screen for a second. And while we're figuring out all these new things, we tend to be heads down in our work and very siloed, which can lead to another problem: duplicated work. When we're exploring new territory and inventing new solutions, it's painfully easy to wind up inventing the same solution over and over again with different people. And by the way, if anyone's wondering what this background image, it's a picture of some grain silos. Get it? Haha. And lastly, how do we make sure all our work and discovery isn't for naught? Because people inevitably leave projects, going on to other projects or other companies, and new people join our projects who need to pick up where others left off. Even without the team rotation problem, when we're working on new things all the time, it's really easy to forget what you were working on just a couple months ago. So how do we record our work in a way that keeps us informed without overloading us with information, useless information down the line? So now that we've defined the problems we face, one second, let's talk about some of our solutions. And I think a good place to start in choosing a solution would be some existing framework for exploring and studying the unknown. And fortunately, there is such a framework. There's the scientific method. It's been around for centuries, it's time-tested, it works. But we're software engineers, not scientists, at least not traditional ones. And we're not doing pure research, we're trying to build something. So we're going to modify the scientific method just a teeny tiny bit to better fit our existing software development processes. So let's take the scientific method we all remember from middle school. This diagram is actually from a middle school science resource for the state of Georgia. And let's clean it up a bit because it's really ugly. It's got a lot of JPEG artifacts, all that stuff. That's better. Although as a side note, this diagram is actually still wrong. Just FYI, there should really be an arrow from refuted to communication as well. Not publishing your negative test results is actually a big problem in the science world at the moment. But I digress. Let's make some tweaks to this classic process. So first off, let's, excuse me. Oh, Zoom took over my screen. First off, let's reduce the observation and hypothesis steps to a single research step. Since we aren't really observing nature to decide what we want to learn next, we want to learn what we need for our project. And let's reduce the analysis and communication steps to a new assessment step. Since we're building a project with a team we're working closely with, not publishing our work to broad scientific journals. And lastly, let's drop this one arrow since we don't really need to repeat our results after we achieve something. We're not trying to prove anything, we're trying to build a product. So now we have a fairly simple process: research, experiment, assess, and repeat as necessary. Let's define each of these steps a little further. So for the research step, our goal is to learn as much about a topic as we can. We want to make sure we learn from a wide range of sources, including everything from dry academic papers and studies to blog posts and news articles relating to the wider social context around our topic. For example, if we were building something with machine learning, we absolutely do want to dig into all the 2-minute papers and TensorFlow documentation that we can. But it's also incredibly important that we read up on things like how implicit bias in training data can lead to discrimination being encoded in AI. And lastly, we want to continue our research until we formulate a handful of ideas worth trying out. You might say a few experiments. So in the experimentation step, we want to test our ideas, and that means building proofs of concept. We want to work quickly, so we don't want to waste too much time here on bad ideas. That means we need to assume that everything we create in this stage will be thrown out, even the successful ideas, because we'd rather spend our time re-implementing our successful ideas once we know that they'll work, than perfectly implementing our bad ideas only to have to throw them out in the end. Our goal in this step is not to build the final product. Our goal is to figure out what we need to do to build the final product. Finally, we want to document everything we've discovered, both for our own reference and to communicate what we've learned to our teammates, to future teammates, and potentially to even wider audiences. So when you're working on the cutting edge, it's a good idea to publish your work. This is a great place, a great opportunity to contribute back to the global wealth of information with our own articles and technical papers and whatnot. But more importantly, we want to present what we've learned to our team members, right? We can share our work via presentations or meetings, or maybe just written reports. But weekly demos specifically is a great place to do this. Once we've shared what we've learned, we want to consider how what we've learned changes our plan going forward and informs our next steps. Now that we've assessed our results, we just have the teeny tiny task of actually building something, which admittedly is a lot of work. But unlike all the prior steps here, it's something we already know how to do and we know how to do really well. But where's the Agile, right? This talk is Agile on the edge. So where does Agile fit into this process? Well, let's take a second to look at what goes into good Agile story writing. So good Agile stories need to have someone in mind that they're benefiting, a beneficiary, like an end user or maybe third-party developers that need to build on top of your work if you're making something like an API maybe. Good stories also need to have deliverables, some kind of artifact like a new feature in an application or maybe a piece of documentation. Good stories can also be estimated. They don't run on forever. They're finite tasks that we can finish. So let's take a step back and look at our scientific-ish method again. Sorry, Zoom. Yeah, so let's look at the research step. So when we do our research step, we want to continue until we have some ideas for experiments to run. In effect, those ideas can be the deliverables in the form of some documentation or as a list of new stories, the experiments we're going to do, to put in the backlog. And in the case of coming up with experiments, to work on, the beneficiaries are ourselves, our own team. And that's okay. We can be the beneficiaries of our own stories if that helps us achieve our project goals. As for estimation, we just have to take a guess at how long it will take for us to come up with a list of ideas. And if we can't properly estimate that, we can always cheat a little bit and time box our research. Say, excuse me, say if we don't have any good ideas in a week, then we know we need to stop and reassess what we're doing. Now let's look at the experiments. So for this stage, we want to figure out what works, which of our ideas are worth pursuing and building upon. Sometimes that answer will be simply this idea or the other, but more often than not, it might be multiple solutions, or maybe the realization that none of our solutions will work and we need to take a step back. Those answers here are our deliverables in the form of experimental results. Again, we are the beneficiaries as the results of these experiments help us unblock work, but this is also a good place to incorporate outside beneficiaries as well. Because if we share our work, even our failures, we can help other teams chart these unfamiliar waters. And as for estimation, this is actually the easiest step since we're just building something. And we can estimate our experiments the same way we estimate any feature we might build. And last, let's look at the assessment stage. So in this stage, we want to share what we've learned with our team, document it, and discuss it. So the documentation of what we've learned and of the conclusions that we've come to as a result can be our deliverables here. Again, our team are the beneficiaries, but if we choose to publish our work, the rest of the world can be the beneficiaries as well. And as for estimation, we just need to estimate how long it will take to write up some documents and maybe have a couple meetings to talk about it. you might be noticing a few patterns here. So the obvious one is that all of these stages can be represented as regular Agile stories. All of these stages also benefit our team by unlocking future work. But most importantly, the outcome of each of these stages, in a sense, can be more stories for the backlog. And as a result, these stages are sort of modular and repeatable. So let's go back to our steps diagram for a minute because we can extend it now. When our research or experiments fail, we can always move back to research. See the arrow from refuted to back to research. But also, when our research succeeds and we find a workable idea, we can move into our usual Agile processes and build things. Or sometimes when our research and experiments do work, we find that the answer is not actually something to build, but that we need a better understanding of the concepts that we're exploring. In that case, we can move to another round of research, experiment, and assessment. And we can continue exploring these ideas. We can also expand on this process as we need with more research beyond this. We can do another cycle, or we can move to working in Agile, in our regular Agile process, and then back and forth between the research as we need. We can subdivide our hard problems in research just like we subdivide big stories in our backlog. And we can move from any cycle in these stages to any other as we need to accomplish our goals. We can do research and experiments when we don't know how to move forward. And once that research and those experiments give us the answers we need, we can move on to building things. Or if they don't, we can do more research and more experiments until they do. And all the while, we can track our progress with documents and proof of concept experiments, and we can manage our work just like any other stories in our backlog or sprint. We can create a sort of Agile ad infinitum. And if there's anything you take away from this talk, I would really love for this to be it. Not just because it sounds really cool and I would love to coin this term, but also because it's a really useful concept. So when we break down our problems into smaller and smaller steps with research and experimentation at the start, there is no problem too big or too complicated for us to solve. It might take a really long time, and that's the cost of working on very complex problems. But at no point in our process do we have to get stuck, unable to move on to the next thing, because we can always shave off just the tiniest little bit of a huge problem to give ourselves something to work on, to start work on. And once we unblock ourselves and get into the rhythm of working, we often surprise ourselves with how quickly we can do amazing things. Let's take a minute to go back to the start of the presentation and the problems we presented there. So, hold on. How do we navigate unexplored territory? How do we do research? How do we, how do we research? We learn everything about, my throat is really bad. So how do we navigate unexplored territory? We do research. We learn everything we can about the territory that we can. And once we know enough to move forward, we take small, deliberate steps to feel out our surroundings. Where do we start when there's no clear path forward? We break the problem down until we find something we can try, and we run an experiment. How do we dedicate time to research without losing velocity? Well, we treat our research as regular stories. We define clear deliverables like reports or presentations to anchor our work, and we present those deliverables back to our team. How do we adapt as our understanding improves? We assess our work as we go. We take a step back, look at what we've learned, discuss it with the team, and adjust our tasks in just the same way that we adjust our plan in every sprint cycle, just like regular stories. How do we make hard decisions? We try stuff. We spend a little bit of time experimenting with each possible path, and we make our choice once we have enough information to inform ourselves. How do we answer questions that have never been asked before? Again, we try things. We tackle these problems just like scientists. We break them down, research them, experiment, and assess our results. How do we avoid duplicating work? Well, we document our work and we share our documentation. We create reports and presentations and proofs of concept, and we take frequent breaks to share our work and communicate it with our peers. And how do we make sure what we've learned isn't lost forever and continue to document things without overwhelming ourselves with useless information down the line? We document our experiments. We select ideas worth trying, we try them, and we document what works and what doesn't work. And hopefully, if we do it right, when another developer joins the project down the line and asks, hey, why didn't we do this other thing? We have an answer. We can say, we have documented experiments to point to, and we can say, we tried that and it didn't work because of X. Or maybe we tried it and it did work, but we chose this other path because of Y. And hopefully that solves our problems. That's it. Any questions? Thanks.